Today we are going to talk about connecting, all the different connections you're going to need. It's important to understand how all components in the studio are connected and different types of connectors that are in our profession. In this chapter we'll cover RCA connectors, quarter-inch connectors, XLR connectors, adapters, plugging in, powering up and down, and grounding and humps. So a lot to cover today. RCA connectors are going to be most common in home stereos. It's going to be these up here. They're also in some professional audio applications, but you'll typically see them in home stereos. Quarter-inch connectors, they're also called phone connectors because they were used in telephone patch bays. You've got two types. Unbalanced, which would be like your instrument connector, so guitar or keyboard or whatever. Then you have balanced, which would be a stereo connector. All right, let's talk about XLRs. They're referred to as a Canon connector. They're a standard connector type for professional microphones. So typically, when you get a microphone, they're going to have an XLR connector on them, and so this would be a mic cable. But they're also used for powered speakers and many other different things. Direct input boxes, things like that. Dual banana connectors are used for speakers. Typically, these are going to be for speakers. They'll go from the output of the speaker to the enclosure input. Speak-on connectors are for speakers as well. They're to connect from power amps. And so it's a simple way to connect amps to cabinets with bi and tri-amplified requirements. That just means they have 2 amplifiers or 3 amplifiers inside of them. So you can make those, it can make it an easier connection. Because you can run through multi-pair cable. Alright, let's talk about adapters. Adapters are convenient when using different cable types, but should be avoided if possible. Adapter can be a weak connection, prone to digital pops or cracks, which can be difficult to remove later. So only use an adapter if it's your last resort. Always try to get the correct cables. A lot of times I'll end up having to solder my own connections. I would rather do that than do an adapter. Impedance, this is the resistance to the flow of electrical current. Impedances are measured in ohms. Okay, and this is a symbol for ohm. Z is the abbreviation used for impedance. So impedance will be Z. Ohm, which is the unit of measurement of impedance, will be this Greek symbol, omega. So high impedance is usually greater than 5,000 to 10,000 ohms. Okay, so if you're in that 5,000, 10,000 ohm range, it's going to be high impedance. If you're in low impedance range, it's going to be 50 to 300 ohms, somewhere around there. Low to high. If you're going from a low impedance to high impedance, there's too much resistance. So there's too much resistance at the high impedance of the amp for the low impedance signal to accurately and efficiently enter. Okay? If you're going high to low, there's too little resistance at the low impedance input of the mixer for the high impedance to accurately and efficiently enter. Okay? So you have to have matching impedances in order for it to work. And like we said, back here, Impedance is just the resistance to the flow of electrical current. So you have to have the same resistance between two connections for it to work. Thankfully, most of our stuff is going to be low impedance, and we're not going to have to worry too much about it, but there will be certain occasions where I'll point out that we need to worry about impedance, okay? Let's talk about lead. It's another word for wire. So a lead is just the cable, basically, okay? So it could be a guitar cable, XLR cable. Forget about the connectors, just look at the cable, that's a lead. Hot lead is carrying a signal. So if that cable is plugged into something and it has power, it's a hot lead. A braided shield is used for instruments, mics, and outboard gear. Anything other than a speaker cable, basically, you're going to have this braided shield right here. And then you can talk about balanced versus unbalanced cables. Balanced is going to have hot conductor and a cold conductor. Unbalanced is just going to have a single conductor. Tip ring sleeve is going to be balanced cable. Okay, tip is going to be your hot. Ring is going to be your cold connection. And then your sleeve is going to be the ground. So the way you would solder it up, your tip, it's going to be like your red wire, your black wire. I'm just throwing these out arbitrarily. They could be different colors as long as they're the same. But you'd have like your red wire be tip, your black wire be ring, and then your sleeve could be your ground. So same thing with this one. On XLR, one is going to be your shield, which is your sleeve, you know, like the equivalent to sleeve. So one's going to be your ground, black wire would be your 2, okay, and then your red would be, black would be your 3 and your red would be your 2. And again, those don't super matter as long as they're the same on both sides. So you could, if you had red as 3 on both sides, you know, it'll work. Talk about the cone speaker. So different aspects to the cone speaker, okay? Start with your dust cover in the middle, your actual cone. This one's a weaved cone. This is your surround, like the insulation. You have your terminals. The spider is on the inside of the actual speaker. You don't have to worry too much about that or the coil former, but the biggest thing I want you to know about the cone speaker is the general workings of it. It's a moving coil speaker that vibrates air, and that's how you hear. Okay, so here's a little bit more explanation on that. Current through the movable coil speaker produces a force either forwards or backwards on the coil. An alternating current causes the force to swap direction and the coil to vibrate. The coil causes the diaphragm and speaker cone to vibrate. Vibrations cause sound waves that travel through the air to the listener. Okay, here's a diagram of that. Here's another diagram of the cone speaker. Let's talk about the crossover. There are 2 types of crossovers, a passive crossover and an active crossover. Passive crossover typically is built into a cabinet and receives full range of signal from the power amp. Active crossover requires electrical current to operate. So how does it work? The example below shows the frequencies of the crossover. Lows are in red, highs are in green. The crossover sends the low frequencies to the woofer and the highs to the tweeter. These different types of speakers are designed to handle those specific frequencies. Some crossovers can be adjusted to accommodate different acoustical needs. So you can see the red is low, right? So in the woofer, you have all this signal, and then once you get to that point, it starts to cross over. You have less and less in the in the tweeter. So same thing opposite. On this side, the greens are high. You have all the signal in the tweeter, and once you go to the low, you have very little signal in there. That's what a crossover does. It sends two different, splits your signal, sends the highs to the tweeter, the lows to the woofer. Let's talk about monitoring. Typically got two different types. Near field. Okay, for up close monitoring, flat response speakers. And you can see you want an equilateral triangle between you and the speakers. And you want these all to be about the same distance and angle apart. And then you have far field monitoring. This brings in the acoustical elements in the room. Rooms should be tuned to the best results, okay? So this is going to be a lot more costly, and mainly you're going to see these at your professional studios. Some of them will have near field and far field. Every studio is basically going to have near field, but then some of your more fancy studios will have far field as well. Let's talk about powering up and down. For electrical power, use a surge protector on all your stuff. You never want to plug any of your expensive equipment right into the wall. Spikes and surges are fluctuations in your electrical current that rise well above the 120 volt current that runs most equipment. Surge protectors are designed to trip so current spots protecting gear. Okay, so powering up, if we're talking about a mixer and power amps and all that stuff, okay? You want to turn on your mixer and outboard gear before the power amps. Always turn on the power amps last to protect speakers from pops. Okay, so you turned on your speakers first. When you turn on your mixer, it'll be a pop. Powering down, you want to do the opposite. Turn the power amps off first, and then turn off your mixer and outboard gear. All right, let's talk about ground hum. 60 cycle hum is a result of a grounding problem. 60 cycle hum has a distinct and distracting waveform. Okay. Also, if you have a guitar in your projects, if you have an electric guitar that has single coil pickups, you will have some 60 cycle hum. It is also directional. So if you have that single coil pickup selected, have your guitarist move to different, not to different parts, but like in different directions of the room, and see where it is the quietest. That's where you're going to want to record. Grounding for safety. Electricity is always attracted to something connected to the earth. The reason for the third, called the ground pin, is to give an electrical problem a place to go. Okay. Your ground lifter is an adapter used to eliminate unwanted hum. So if you're having a hum problem in, say, a keyboard or a bass guitar that's running through a TI, there could be a ground lifter that eliminates that. And a lot of those are built into like direct input boxes or things like that. Mixers, things like that. All right. That's our conclusion. Okay, that's what we wanted to accomplish. Okay. All right. And then the last thing, you saw this on the preview. Here's a picture of every, I don't want to say every, but most types of connections that we're going to be using. I don't see a speak on here, but mainly everything else. So it's the ADAT connector. If nobody's ever seen an ADAT connector before, you're probably all familiar with FireWire of some sort. SPDIF and RCA are the same thing. XLR, mic cable, right? BNC is going to be typically where I see BNC connectors are for antennas for wireless microphones and things like that. We'll typically have a BNC connector. A tip sleeve, or TS, is going to be like your instrument cable, right? TRS is going to be it's going to have two rings on it. It's going to be a balance cable. and regular RCA and MIDI. Alright, and then so here are all the male connection types, and then the top row up here are all the female connection types with the look. Alright, that's all for this week.